Hello, good afternoon, everyone.
Good
Hello,
afternoon.
good afternoon. Yeah,
Good
good afternoon,
afternoon.
sir. Hi, how are you doing today, sir?
Very much fine. How are you too?
I'm fine.
Yeah. Good to
Yeah,
hear your voice again this evening.
and you too, and you too. Yeah. Hi, good afternoon, Yenka, Chibuzo, Joseph.
Good
Good
afternoon.
afternoon,
Good
Samson.
afternoon, everyone.
Yeah, yeah, good afternoon.
Good afternoon.
Welcome to today's session. Yeah, good afternoon. Trust we are doing great. So we'll be kickstarting the session now, like made mention yesterday that we'll be starting at 4 on a dot. And today we'll be looking at data modeling. And I had informed us yesterday that a friend and colleague who is an expert when it comes to data modeling will be handling the session today. So I'll be calling on Muhsin Hameed to introduce himself as he kickstarts the session with you guys. So I believe that it will be a very interesting one. So Muhsin, over to you, please.
All right, thank you, Samson, and good evening, everybody. Please, can we hear me?
Yes, I can hear you, Muhsin.
Okay,
Can
good
hear you, sir.
evening. Okay, great. Good evening. So thanks a lot for joining in, and I welcome us warmly to the Microsoft Eastern Power Platform community. I'm aware this has been on for quite a while. Probably this the second week or the third, if I'm not mistaken. And today we want to look at data modeling. Just to be sure, or just to ask, what do we think of data modeling? Has anyone heard of data modeling before? Or is this something that's pretty new to us? Anyone with an idea? Or it's new to everyone?
So I think
Okay, go on Sunday.
all right, sorry I didn't raise up my hand before. I'm sorry. Okay, so for
It's
me, I
fine.
think data modeling has to do with relationship in data, as in
Hmm.
bringing different data together and connecting them using a common ground. That's my little understanding. Basically relationship.
Basically, relationship. Thanks a lot for that. I like that keyword there, relationship. Joseph, your hand is up.
Hi, Muhsin. Yes, so Sunday has basically highlighted my point is creating relationship between data, like bringing different tables together and connecting them to a common with a common identifier. So Sunday has highlighted that thing.
Oh, okay, great. Thank you so much, Joseph, for that submission as yes, we're on track. So when we talk about data modeling, well, in a way, it has to do with relationship, but there are reasons why we would want to do that. And so those are some of the things that we will be looking at in the session today. And just Samson, yes, we know Samson. Samson is the host and the organizer for this. Um, I'm sure he has introduced himself a couple of times, so let me not take our time with that again. And this is me. My name is Muhsin Hameed, a business intelligence analyst, Microsoft certified, and I have a couple of other certifications. I do a number of things, but my core is in business intelligence, and I do automations. Yes, RPA development and stuff. So we can connect on Twitter. I have a YouTube channel as well at ID analyst underscore analyst, and we can connect on LinkedIn. So that is just a brief about me. So what we'll be looking at today, first off, probably if you have questions around what has been taught so far, I know we've had some sessions on Power Query, we've done some things on cleaning data. We had some conversations around data generally, so the data roles, types of data analytics, and some stuff. So if you have any questions around that, so probably would start off with that before we go into some other things. So we'll be looking at data sources because this forms the foundation of whatever thing we're doing when it comes to modeling. So you don't just want to model your data. You should understand why are you modeling your data. You should be clear what are the reasons why and how should it be done based on the kind of data sources that you're using. And then we look at why data models, what is a data model and what is data modeling itself. So we have a clear background around all of this before we now see how exactly data modeling is done in reality. So this will be the guide for this session, and I hope that we are able to cover every of this in the time frame that we have. I'm aware we have 90 minutes to run this. So as we go on, if you have questions at any point in time, please do call my attention to that so that we don't necessarily need to pen our questions till the end of the conversation. So if I'm discussing a concept and it seems unclear, let me know so that I can get back to that and we see to clarifying whatever ambiguities we have on certain concepts before we go on to what is next. All right. So the ground rules, punctuality, one class, let's have open mind, let's mute our microphone, let's ask questions. Yeah, that's the most interesting part to me. Questions. The essence of being here is so that we add we share knowledge. That is the essence of being here. So if we're here and certain things are not clear, let's not be shy to ask our questions. We can ask as much questions as our time would allow. And for whatever question I have answers to, I would give answers to them. Of course, there may be some things you would ask that I don't know, maybe. So, but for whatever thing you have, you want to make, you want to clarify, please do let me know so that I can have those clarified before I leave the session today. So like I mentioned, the first thing we starting with is just so to be sure we don't have things to clarify from the previous sessions. Any question from what we've done so far? Anybody has a question? Probably what we did yesterday, before yesterday, so we quickly have those clarified before we proceed. Any questions? Okay, I suppose not. All right. So now, okay, Sunday, your hand is up. Please go on. Hello, Sunday, you're muted.
Oh, my apologies, my apologies. So I was going to ask, I've heard this word interchangeably. I don't know if they're the same or they're different between them. Between a Power BI developer and a Power BI analyst. And maybe I should further extend it to say, okay, though I kind of have a fair idea about what a data analyst is, but what's the difference between a Power BI analyst and a Power BI developer? I think I've heard these two words. Are they the same thing or do they mean different things?
Okay, thank you so much for that question. Power BI analyst and Power BI developer, they are different contextually. So although in some organizations, they may put it out that they want to employ a Power BI analyst, but eventually when you get in, you'll be doing the work of a Power BI developer. So practically, the difference is that when you're a Power BI analyst, you are doing data analysis, which I'm sure that we understand what that nomenclature means. You're doing data analysis within the Power BI ecosystem. So everything you're doing revolves around Power BI for analysis. So you're using Power BI Desktop to develop your report. And after developing your report, you are publishing it to the Power BI service. You're sharing with people, you're doing presentation. Everything revolves or sits within the Power BI ecosystem. That is what a Power BI analyst does. But when we talk about Power BI developer, so Power BI developer practically means that you're a BI developer to start from there. So and as a BI developer, what you're doing is you are not just analyzing data. Many times you are doing some sort of ETL yourself. You are pulling data yourself based on the business requirements, based on the answers you want to, the questions you want to provide answers to for the business. And in a way, you are also doing the work of something related to what database developers do. So the clear difference is this: as a Power BI analyst, you are not naturally meant to be querying data yourself from databases. We understand that different organizations, they have different ways of storing their data. We'll get to that. an organization might be using SQL database. So as a Power BI analyst, what is expected is you have been given access to what data you need. You have that data already, and you just plug it into your Power BI, and you go on to analyze it. But as a Power BI developer, so what you do is a bit beyond that, in the sense that you are the one working on the database yourself by pulling out the data, writing your query languages, bringing it into your Power BI, which is a step above what a Power BI analyst would do. And then you are doing you are then doing what Power BI analysts would do. So essentially, as a Power BI developer, you are expected to know database languages. So maybe you have idea of should know of SQL, SQL, or you're writing some NoSQL languages or whatever. Probably you're working with a data warehouse or data lake or stuff. So you need to be aware of databases before you can be a BI developer. But as an analyst, you necessarily do not need to know much about BI, about databases. Of course, it's fine that you know how they work, but you may not be able to really query data yourself or do some transformation right from the databases yourself, but you are able to create your report dashboard based on whatever question you want to ask or you want to answer. I don't know if that's a bit clear.
Yes, thank you, Muhsin. That makes sense. Thank you.
Okay, great. All right. So let's go into what we have for today. And when we talk about data modeling generally, although later on I will give us some definitions based on what I'm able to lay my hands on. But when we talk about data modeling, essentially it all starts from data sources. Before we can do anything within Power BI, let me put this to us. Everything that we want to do within Power BI has some things that we need to be aware of. So we have what is called the building blocks of Power BI. I don't know if probably that has surfaced in our previous conversation. So when we talk about the building blocks of Power BI, there are 5 things essentially that you're doing whenever you're working with Power BI. And the start point is data. For whatever analysis you want to run, you must have data. That is where it begins from. So if you don't have data, definitely you cannot run any analysis. So that is why many times when you are asked to do analysis of something, you do have access to that data. And if you do not have access to the data, then obviously you have been directed or pointed towards where you would get that data from. Without data, you cannot start off anything. So, but this data, they sit in different places. You could have your data sitting maybe in Excel. You could have your data sitting in a CSV file. You could have your data sitting in a relational database or somewhere. Your data is just sitting somewhere. Where your data sits is one of what would define how you're going to model your data, or what modeling would you do, or do you actually need to model your data? That is why we need to understand data sources. So if your data is sitting in a particular data source, let's say your data is sitting in data source A, it could be that you don't need to model that data anymore. It has been done already, and you just go with your analysis. But if your data is sitting in database B, it could be that because of the fact that it is sitting in database B, then you need to go on to model that data first before you go on to analyze. What is data modeling? We'll get to that shortly. So let's look at our data sources. So when we talk about data sources, essentially we are talking about 2 things. We have our databases and we have our flat files. Databases, they are clear. Everyone knows databases. That is where you store your data. That is where data is meant to be stored. Let me say that, because people use some other files as databases, which are not primarily their purposes. So, but databases, the purpose of a database is so to allow you store data, and they have been built for that very purpose. Flat files, these are files that are text files, but they store records. Text files that store records. Again, we have databases. Your database stores data, all forms of data. It could be text, it could be numbers, it could be pictures, it could be music files, it could be PDF, it could be whatever kinds of files. You can store them in databases. But when it comes to flat files, your flat files primarily store text data type, and the text data type that it stores comes in forms of records. So we could say that the first record we have on this file is talking about Sunday, and then the next part of that record tells us where Sunday lives, date of birth, and a number of information around Sunday. So which means that every single line that you pick on that file would be a complete record of whatever the file is talking about. So that is what a flat file is. Then when we now talk about databases, we have basically two types. We have the relational databases and we have non-relational databases. Relational databases are those databases that are in table format. Put it straight. There's so much buzzwords around it, but to be straight with it, any database that stores data in form of tables, those are relational databases. Relational means table format. That is what it means. And when you say a database is non-relational, it implies that that database is not or does not store its content in table format. Again, we have two categories for data sources. You could have a database and you could have your flat files. Your database can then be broken down into relational and non-relational. So for relational databases, you are storing your data in table format. So you have table A, you pull it into or you push it into your database. You have another table B, you push it into your database. Another table C, you push it into your database. All of those, they are tables. And the reason why they can sit into your database is because that database is a relational database. That's why it can accept all those tables. Your non-relational databases, they are databases that do not store data in table format. We have different types of this. You could have your key values, you could have your columnar, a number of them, documents and stuff. So, but essentially is that non-relational databases, they do not store data in table format. So you could have PDF files, you could have your normal documents, you could have JSON files, XML files, a lot of those pushed into your non-relational databases because your JSON file is not in table format. It is in dictionary format for those of us that we know a bit of programming. So when we now look at examples, for your relational databases, you could have your SQL databases, your SQL, MySQL, and stuff. All of those are relational databases. They store data in table format. And for non-relational databases, you could have a MongoDB, Cosmos DB, and all. So those ones, they do not store data in table format. So it's a different conversation entirely to have a deep dive into databases because there are a lot of terminologies, there are a lot of technicalities around it. But I'm just using this to set the pace for what would have as our conversation after. And for your flat file, you'll be looking at your CSV files, you'll be looking at your TSV and Excel files, text files, and stuff. So what is a TSV file? Anybody has an idea? Have we heard of that before, TSV? Or let me start with CSV. What does CSV mean? Okay, Sunday.
Okay, so my basic understanding that CSV is like a comma separated version of files, a files that are separated by commas. They're not in tape, they're not in columns, and they're not in row per se. They're just separated by comma.
Excellent. Thank you for that. Ido, you want to say something?
Yeah, that is exactly what I want to say.
Okay, great. So CSV files, they are files that are separated by comma separated values. That's what CSV means. So which implies that you have something like a text file, probably if you open it on your notepad, and you just see that individual values or individual data point on that file is separated by a comma. That is what CSV means. TSV means tabs separated values. So instead of comma separating your values, you're having your tab. When you press tab on your keyboard, you're having that as the separator. It is called delimiter. And you have a bunch of Excel files. So Excel file could be XLX, it could be XLSX, it could be XLSM, it could be XLSB and stuff. All those Excel files, they are all flat files, because when you look at each of the rows that you see there, it's a complete record about whatever is being said there. So having said this now, so let's go into the reason why I would want to build a data model. We have a situation, and at this point, I want us to open our, we have one file that was sent to us, one of the files that was sent to us. I think it was tagged, let me confirm that again, denormalization, yeah. So let's open that file. I just want to show us something on that file. I'll put that up on my screen as well, just a sec. Okay, so I'll put it here. So now, if we are looking at for this data set now, we have been asked to analyze this. Our line manager has told us that we should run an analysis on this, and then we showed, first is, he wants to know what our total revenue is. Is it possible we get our total revenue from this data? Yes or no?
Yes, we can.
We can.
So your screen is still showing welcome to Microsoft Instant Power Platform.
Is that what everybody can see?
No, I can see the Excel from my end.
Okay.
I can see the Excel sheet from my
I
hand.
can see the Excel from my end.
Okay, great. I think, was I Yinka? Please, you may need to check your internet. Maybe there is a lag there. So now, we all agree that we can get what our total revenue is. Excellent. Can we, another question is this. Our line managers asked us to find out in which quarter of the year did we sell the most? In which quarter of the year did we sell the most based on this data set? Is it possible we get answer to that from this data set?
Yes, we can, using the trade date.
Using the trade date.
The trade date, yes.
Excellent. All right. So now, he now went further to ask that he wants to know which of our customers brought in the most revenue. Which are most which are best customer, if that's the right word. Is it possible we get that also from here?
So okay, so I can see line of business. I don't know if that also means the customer's name.
No, line of business is, for instance, if in our business now, maybe we are, maybe our company is Chi. That is our company. So we have a number of products, you know. So this line of business, they are like our products line. So maybe in the products line for beverages, so we have a number of things that we produce under beverages, and we have another products line for, say soft drinks. We have a number of products there. So line of business is just like different products lines in the business. So is it possible?
So is it safe to say that the store name, it can be the customer, can be the customer's name?
No, store name is just the location. Look at your store name. That is where that store is, Abaji. And Abaji is in FCT Market. FCT Market belongs to the North Central region.
Okay, for that, I think they will have to supply us with more information regarding the customers. So we will now build a relationship based on that.
Excellent. So many times, some of the questions that we want to answer from our data set, we cannot go on to answer them because we do not have that data. On this data set that we have before us, we do not have anything that is talking to the customers. There is nothing about our customer here, which implies that we cannot say that if you look at this first record here, this first record, we cannot say that this record was, or this revenue was brought in by anybody, except probably if we have a customer column here, and then we have something like something here. So this is what would tell us that, okay, this revenue was brought in by something and it got this unit sold, this number of units for this particular product. But because we do not have a column like this on our data set, it will be difficult for us to now say that this customer, or to answer the question of which customer brought in the most revenue. It will be difficult to say. And for that reason, one of what you would want to do is to say that, okay, you've asked me to create a report of our customers by revenue, but I do not have data of our customers. Where can I find that? Then they say that, okay, our customers, we have a second data sheet here that is for customers. And then the question will now be that, how then can I connect the data set which houses all our customers to our actual data wherein we have our transactions? And that is one of the biggest reasons why you would want to model your data. So you want to model your data such that you have different tables of data and you want to establish a relationship between them so that they would be able to speak to one another so as to enable you to answer your business questions. All right, so let me go back to this. For us to get to understand why to model data, that's what we started with. You want to establish connections or relationships between different data sets that you would need to answer your business requirement. That is one of the reasons. But let's quickly look at what data model is. A data model, they say, represents the framework of what the relationships are within a database. I want us to take note of some things here. One is, take note of database that is here and relationships. So what a data model is what shows the framework. It shows the framework of what the relationships are within a database, which implies that what you would typically experience is that a data model most likely would already exist within a database, or a database is meant to have a data model. Either ways. What I'm saying with this is, if you have a SQL database within the business, your SQL database most likely will have a number of tables. Maybe on a table, you have your transactions. You have another table for your customers. You have a table for your products. You have a table for business managers. You have a table for your sales reps. All of these tables already exist within your database, and then you have now found a way to create a relationship between all of them so that you would be able to build a report of your sales rep by revenue. So you want to know who is your most performing sales rep, how much are they bringing into the business, so that probably that would allow you calculate what their commission would be and stuff. So all of these tables already exist within the database, and then what you need to do is to just establish a relationship between them. So what now gives you the pictorial view of the relationships that exist within the database is a data model. So let me show us something here. I'll bring up a Power BI report wherein we see a simple model here. Just a sec. Okay, let me just do this. No, okay. All right. So I'm sure we are familiar with the Power BI interface now. So if you look at this, this is a data model. I have a table here, which is my transactional table. This is where all my transactions are recorded. And I have different audit tables that are connected to this. They are related to this. So this is a data model. This because this shows what the framework of the relationship looks like within the database. This is not the data itself. This is just the model. So the model just shows, it's just a pictorial view of what the different connections and relationships are within your database. Again, this is a simple model. You could have some models that are very complex, depending on the way, the number of tables, depending on the way those tables are related to themselves and stuff. So let's get back. So what I'm trying to drive out with this is, when you talk of data model, think of a picture, something that represents how your tables are related to one another within your database. That is a data model. So now, but what we talk about data modeling. So IBM defines data modeling as the process of creating a visual representation. That is still the framework that we talked about, of either a whole information system or parts of it to communicate connections. So connections, which implies relationships. So what you're doing when you are modeling your data is that you are trying to create a representation of the system you're working with, so that you are able to communicate to people. Whoever is looking at that system, they can see the connections that are inherent, that are within the system, what kinds of relationships are there between your data point and structure. So between your data point, between your tables, you are able to see what kinds of connections exist there. So that is what you're doing in data modeling. So data modeling, to put it straight, you're trying to establish relationships between different tables that exist within your database, and then the result will be a data model, which is just a picture of how those tables are related to one another within your database. So that is what data modeling is about. But before we go into the demo, so let's just quickly clear some things here. There are some terminologies we'll begin to use so that we are a bit clear. So when we're talking about keys are, look at it this way. If we want table A to talk to table B, there has to be something that would create that connection between them. David wants to speak with Yinka. David wants to speak with Yinka. David is in Lagos. Yinka is in Port Harcourt. For David to speak effectively with Yinka, there has to be something that would establish that connection. And probably that will be maybe mobile, maybe email, or some stuff. There has to be something in between. So that is what your key would do. You have table A and you have table B. You want table A to be connected to table B, then you need a key which would allow you access to each of these tables. So table A would use the key to talk to table B. Table B will use the key to return whatever table A has asked it to return. There are two kinds of keys. We could have a primary key and we could have a foreign key. Your primary key is the key that is coming from your dimension file. I'll get back to that. So you have your primary key to be, or your keys generally are your meant to be what would establish the communication, and as well they are meant to be unique. So it has to be something unique to both tables. So in table A you have column A, and table B you have column B. Sorry, let me show us something in Excel. So this is better put into context. So if you have something like this, we have table A, and then we have table B. Okay, so and table A, we have columns A, B, C, and table B, we have columns B, D, C. Okay, so before table A can speak to table B, there has to be something that is common between the two, which is C in this case. Okay, let me just make this E. Okay, so which is B in this case? So we have B on table A and we have B on table B. So that is what we can use to create that connection. There has to be something which is common. So now that thing that would allow us create the connection is called a key. So we have a key on table A, which is the same key that's available on table B. So there are two kinds of keys now. We have the primary key and we have the foreign key. Look at the primary key as that key that is completely unique, in the sense that it is possible that on table A, we have duplicate values on table A. Okay, we have duplicate values on table A. And on table B, all our values are just totally unique. Nothing is duplicated on table B. So if on table B, we do not have duplicate at all, which means we would have one key on table B. Table A, we have many keys. So for table B that has just one key, it means that that key is the primary key. And on table A, where we have many of that kind of key, then there we would have what is called the foreign key. Is this clear, please? Or I should take it again?
Please, I don't
Please
mind.
take it again.
Trying to, yeah.
Okay.
please take it.
Okay. Okay. So what I'm explaining is this. We have two tables like this. Two tables like this. One is our transactional table. Okay, let me do something from here. Let me just do this. So this one. So now I can come here to so then I can also do something like right. So now let's assume this is our table A. So here I can just say call this table A, and here I can say table B. Right. So now everybody, let's look at these two tables. We have table A and we have table B. What do we think is common between the two, table A and table B?
The region.
Table, the what?
The region.
The region. The region. Excellent. So now, what we have here is the unique values from this region column. So if I return the region column here, I can say that where is this? So I can pull in. Yeah. So now this is the region column, which has how many records here? We can see how many records do we have here. So if I do this is 30,801 rows. So which means we have duplicates there. Those regions are repeated. And we have a second table here, which has just six values, which are just unique values. And they are the unique values from this region column. So everything we have in region column, they are from this, but they are just duplicated on the region column because we have different transactions, so many transactions that happen in each of the regions. So that's what this means. So now, if for whatever reason, we want to establish a relationship between this table and this table. So want to create a relationship between these two tables, then what we will need to do is to find what is common between the two. So we have a region column here and we have a region column here. Let's just assume that we have another column here, which we do not have at the moment. So we have a region column here and we have a region column on this table. Apparently, that will be our key because those two columns are common on this the two tables. We have them appear on the two tables. The next thing now will be that which one is now our primary key and which one is a foreign key. We have identified that our region is the key because that is what we can use to create a connection between these two tables. That is what is present on the two tables. But what would be our primary key? The column or the table that would have our primary key is the table wherein the key is unique. The values that we have under the column that we are using as the key has to be unique. That is where our primary key would be in. And that same column on the other table, wherein we have the values duplicated, would be the foreign key. Do we understand this?
Yes, I think it makes a lot of sense now. So that means the column that have all the duplicates and all the whole data is where the foreign key is, while the ones that
Correct.
have the unique values is where we have the primary key.
The primary key, correct. So that is you just assisted me to summarize it. All right. So then we have what is called a fact file and dimension file. So when you have transactional data like this, and you want to model this, what happens typically is you are breaking down the table into what is called a fact file and a dimension file. So see your fact file as your transactional file and see your dimension file as the file that just gives context to your transactions. I will open the second file that was attached to our email. So let me just get to this. So to put this into, yeah. So if I come here now, if you look at it, on this file, we have, this is 5 worksheets. We have 5 worksheets here. And here we have, this is our data file, which is, it doesn't have all the columns that we have on the main file. I'll tell us the reason later. So this one is set to be the fact file, and we'll see what the fact file would be when we start the modeling itself. But these other ones, they are the dimension files. So I would explain better when we get to that. So I just wanted to go into the demo straight off. If I get back to this is the output. This is the result that we want to get. A data model, which is showing us what we have within our database, what is happening there. This would naturally be present within your relational databases. So many times, if you are to create a report and you are connecting to a SQL database, for instance, you have a data model like this already existent in that database. So you are not doing data modeling most times if that database was correctly configured. But if you are working with a fact file, such as an Excel file like this, then you might need to create a data model like this, because if you look at this, we have a single table here, and you may need to break this table down into different tables that would allow you, that would optimize your report. And I'll give us some reasons why you would want to do that. One of the basic reasons why you would want to break down a single table like this into different tables is so that you remove redundancy within your data. You remove redundancy. So many things are redundant here. How many unique values do we have here? 6, just 6 unique values. But this was repeated 30,000 times. Here, probably we have about 30 something unique values and was repeated 30,000 times as well. This one also, maybe we have about 100 unique values and was repeated about 30,000 times. It means we have a lot of redundant data here. So if you are working with a data set that runs into 1,000,000 rows, 2,000,000 rows, then that is when you feel so much of the impact of not breaking off your tables. It is called normalization. For you to normalize your tables, that is one. The other reason why you would want to create a data model is that it allows you a bit more of flexibility when you are doing your calculations within Power BI. So probably when you get to the sessions on DAX, you get to understand this a bit further. But why we are using a flat file to create this is so that we have an idea of how modeling is done. And probably in the future, if you want to go into database administration, you want to go into data engineering and stuff, you already have a background of how data modeling is done, and you can transfer that same knowledge into creating data models within your databases. So we start off now. So I want every one of us, please, we should be with our files now. But the first thing we need to look at is this. On this file, denormalization, how many columns do we have there? How many columns do we have?
10.
10 columns. 10 columns. All right. Then if we go to the second file here, which is historical sales data. If you look at the data worksheet, how many columns do we have here?
8.
Sorry?
8 columns.
8 columns, which means that some columns are not here. Another thing is, if we go to the date worksheet, what can we see on the worksheet? How many columns are there?
11.
11 columns. But on our data worksheet, do we have dates there?
Unless we have to look at it again. I'm not sure I took note of that.
Do we
Yes,
have dates?
there is straight dates there.
There is straight date here. Excellent. So which means that if we look at our date worksheet, we have a date column which could be the same thing as the trade dates that we have here. But the advantage that this brings more is that we now have some other attributes of that same day. So we can look at the year, we can report by month number, we can report by month name, can break it up by quarter, and you don't have to write some complex calculation before you get to this. So by you just dragging and dropping, you are able to answer questions around what's revenue per quarter, what revenue by day category, what's revenue by week, and stuff. So let's go now. We want to create a data model. What are the steps? Typically, we have 5 steps. We have 5 steps when it comes to creating a data model. And step 1 is that you need to list out all your reporting fields. Please, let's note this down. Step number 1 for creating a data model is that you need to list out all your reporting fields. How is this done? What are the reporting fields? Your column headers. Those are your reporting fields. So I'm not meant to use this file. So let me go to this. Yes. So your column headers, they are your reporting fields. So you have to list them out. So what I will do is I will just copy this. I want to build my data model on this worksheet. So I want us to do the same. So I would say step 1. Step 1. Let me see, not sure I copied it. Okay, so I'll copy these headers and I'll come here and paste it here. So these are my reporting fields. All the column headers are here. Everything, 10 columns. So they are here. That is what step 1 is saying. It says that we should list out all our reporting fields. After you have listed out all your reporting fields, then the next thing you would want to do is to now group them into 2. You have the categories and the values. When we talk about data generally, there are 2 types of data. Who has an idea what they are?
come again with that question.
There are two types of data. What and what?
Numbers and text.
Numbers and text. Any other idea?
Date. We have date.
Okay. So basically, the two types of data that we have is either quantitative or qualitative. Okay. Quantitative or qualitative. Your qualitative data is also said to be categorical. And literally, you could say number and text, but in a more data-centric manner, you say quantitative and qualitative. So what this is saying, what step number 2 is saying is that you now need to group your data into values and categories. Values and categories. So what are values? You look at all the columns that you have in your data. Your value fields are the fields that you can perform calculations on. Maybe you can do a sum, you can do an average, you can do multiplication and stuff. Those are the values. So which of these columns can we perform calculations on?
The revenue and the units sold.
Revenue and units sold. Do we all agree? Is that all? If you wanted to say something?
Yeah, that's all. That's all. He's right.
What's the question again?
Okay. Which of these columns can we perform calculations on?
Okay, you've already been given an answer.
Yeah. So revenue and units sold. So those are the values that we have here. So we can just come to where we have revenue and units sold and put a V. So those are the values. And any other thing that you have on your data set that is not a value is a category. So because what your report would typically look like is you are trying to get revenue by line of business, revenue by model, revenue by fiscal period, revenue by store, revenue by market. That is mostly what you'll be doing in your reporting, which means that every other thing that you have that are not values, they are categories and they are only giving context to your figures. So when you look at your revenue to be 76 billion, for instance, so it's telling you, and you now break it down by model. So it's telling you that how much came in from each of the models. So that's giving context to it. So every other thing here, they are categories. So I can just put a C here to tag them as categories. So we now go to step number 3. Remember, step number 1, what we did was to list out all our reporting fields, which are typically the column headers. Then step number 2, we categorize them into reporting lines or values, categorizing them into categories of values. So your values are the columns that you can perform calculations on, or you can aggregate. Any other thing that you cannot aggregate is a category. Then your step number 3 now is you look at your categories and find out which of them are related. If you look at, for instance, now, region and market, are they related?
Yes.
Okay, so which belongs to which?
I think the market belongs to the region.
Excellent. So you look at all your categories that way and you put together, you group together which of them are related to one another. That is what you are doing on step number 3. So now let's look at all of these. Which of them do you feel are related? Which of them?
So store and trade dates can also be considered.
Store and trade dates. Let's look at our data to be sure. This is store and trade dates. How are they related? When we said region and market are related, what kind of relationship there?
I'm looking at location.
Location. Excellent. So now, if we now, sorry?
How about fiscal period and trade dates?
What's the relationship between fiscal period and trade date?
Um, Dates and period.
Date and period. Excellent. So now I would come here to trade date and fiscal period. I can call this one D1, just giving it a tag so that I know that these two, they are related. And then let me come back. So now we said region and market are related. Is there another thing that's related to region and market?
Store.
The store.
Store. So region, market, and store, they are related and they are all talking about location. So I can group the three together. So I can say this is D2, all of these. So which other ones are related? So let's look at it again.
Model and business line.
Model and business line. Are you sure?
Because the model of what we are selling is related to the business line that we are trading in.
Okay. Okay. Let's leave model and line of business for now. Any other thing that's related to what? Day category, is it standing alone or
I
related
think
to
this
something?
category can join period and dates.
Can join, excellent. So day category, because that's also talking about dates. So we come to day category, you give it the same tag as your trade date. So I'll come here and say D1 again. So, and model and line of business, they are not actually related. But if I want to prove that to us now, it eats a bit into our time. So that's why I'll skip that for now. Probably if we are having another session later in the future, we can look at why they are not related. So, because if you look deep into the data, we would understand why they are not. So I'll just say this is D3 model and line of business D4. So that's all. So we have grouped all our categories this way. Then step number 4 is now saying that, step number 4 now says, we now look at all the groupings that you've had. We've said that our D2 is region, market, and store. Try to figure out which one has the lowest hierarchy. When we say lowest hierarchy, this is what we mean. If I say Ikeja local government belongs to which state?
Lagos State.
Lagos State. Lagos State. Thank you. Now, and Lagos State belongs to the Southwest. So let's assume that I meet someone and the person tells me that he is from the Southwest. Is it possible that the person knows that? Is it possible that the person knows, or is it possible that I know which state the person is from? The person just tells me that he's from the Southwest. Is it possible I know his state?
So are you supposed to get that data outside, or are you supposed to assume a state?
No, this is now Sunday. I ask you, where are you from? Then you tell me you are from Southeast. From that information, is it possible that I know your state?
Yes, it's possible, but you might not be able to get an accurate state. But all you just need to do is just get all the states in the Southeast.
Okay, but I can't be accurate. That's it, right? It's
Accurate.
just be some guesses. Great.
Yes.
But now, if you tell me that you are from Edo State, for instance, is it possible that I know your region?
Yes, very possible.
Very possible, because what I just need is Edo State belongs to which region? South. That's your region.
Yes.
So what lowest hierarchy means is that if you are looking at these categories here, these three things that we have put together, region, market, and store, which of them do I need to know that would inform me of the others? So for instance, if I know the region, is it possible that I get to know the market and the store? Or if I know the store, will I be able to know the market and the region? Which is now, the list is, the one with the lowest hierarchy is that field that once we know it, we have known everything in that category.
So
So
I
what
think
is the response?
I think if you're able to
Sorry?
know this, I think if you're able to know
Yeah.
the store, you'll be able to
Mhm.
know the market and you'll be able to know the region.
Okay. Thank you for that. Anybody else? What do we think?
I also think the store.
The store. Yeah. Because if we look at our data set, Abaji as a store belongs to FCT market. Same as Bwari and Gogolada. All of them belong to the FCT, and the FCT is in the North Central, which means that we have more things in the store belonging to a single thing in the market, and many things in the market belonging to a single thing in the region, which implies once we know the store, someone tells us that his store is Gwagwalada, then we know that the market definitely is FCT, and we know definitely that that is not central, but not the other way around. So since that is the listing that we need to know, then we just come here and say that the store here is our key. Can give it a key. That is our key. So let's look at the other ones. We have another dimension. Trade dates, fiscal period, and day category. Which one has the lowest hierarchy?
So day category.
Okay, day category. Okay,
Sorry,
I'm
sorry.
coming.
Trade date. Sorry, because from your
Trade
trade,
day.
you'll be able to tell which one is a work day and which one is a public holiday from the dates.
Okay, thank you for that. Yinka, you have something?
Yeah, I want to say trade date too. I agree with him.
Trade date. Yeah. So trade date, because trade date is the listing. Fiscal period is about, I think it's typically the month. That's what the fiscal period is here, typically the month. And then your work day, a work day might have a couple of days within. So and probably your Monday to Friday is tagged the work day. So it's trade date. So I'll come here for trade date, I will put a K, which is the key to this category. And for the remaining ones that do not have any other member within their category, they are also the keys. So that is step number 4. And step number 5 is now saying that you now build up what is called your fact file. And your facts file is the summation of your keys and your values. That is your fact file. So here we have a key here. So this will be a member of the fact file. We have another key here. This will be another member of the fact file. We have 2 keys here. Those will be members of the fact file, and our value fields will be members of the fact file. So this is we have built our model now. This is how our model would look like. So now, just to make it a bit more pictorial, so we'll have a file or a table that we call the fact file. Let me call this fact table. What am I typing here? Table. And then the columns that you have under your fact table will be the Fs. So what F do we have here? We have the store. We have the store. We have the trade dates. Then we have what again do we have? The model, the line of business, and then we have our V's, revenue, and units sold. Okay, these are the things that we have under our facts table. And then we have what is called the dimension table. So the dimension tables were things that we categorized together as our Ds. So we have a dimension table for region, market, and store. So can I just copy this and paste this here? That will be a dimension table. And this ones we have said is talking about location. So we can call this location. And then we have our trade date, fiscal period, and day category. I can also copy it with this. And then this ones, they are talking about date. So we have another one for model, and we have another one for line of business. So eventually we would have 5 tables like this. This is table 1, table 2, table 3, table 4, table 5. And that is exactly what we have on our, where's this other file? Let me see, where's this file again? Not this, so just a sec. Okay, I think I closed it. So let me bring this back up. I hope it's this. No, it's not this. But that's the other file that we have on our that was attached to our email. Not sure why that's not opening up yet. Okay, yeah, it's here. So that's exactly what we have here. That's how this always got it. So now, how do we then load this into Power BI? That's the last thing we want to look at before we take questions. So we have this table here. We have already created our data model. So remember that what we have here is just is our columns. These are the columns, and that's what we have put together on this file. So if you look at your data, you see that you have the store, which is the key to location, trade dates, which is the key to your dates. Our fiscal period is not meant to be here actually. Then you have your model, you have the line of business, you have the revenue and unit sold. So this one and this one, they are not meant to be here. So what you should have is just this, and that is exactly what you have under your facts table. And the same thing for your location. So if you look at the region, it's called D region here. You see that you have 3 columns here: region, market, and store. That's what you have. So now, if you now go into Power BI, let me bring up a blank Power BI file. I'll bring up a blank file. So just this. And if we want to bring up, if you want to connect to a data set, how do we do that? How do we do that if you want to connect to a data set?
Get data.
Get data.
Get data.
I go to get data. So now I'll go to get data. My data is sitting on Excel. Then I can come to download and this, then I'll click on open. So once I click on open, it's going to open the navigator. And here it's asking me to select what I want to connect to. Remember that here we have all our worksheets here.
Sorry, how did you
We
get
have
to the
all our
navigation?
worksheets.
Sorry.
Sorry? I didn't get that.
How did you get to the navigator? Sorry.
Okay, so now this is what we do. You come to get data, Excel workbook, or you can click on Excel workbook straight from here, or click on it from here. Anyone works. So once I click on Excel workbook, it will ask me to go to what data I want to connect to. So I'll come here, this is the data file, and then I'll click on open. So once you click on open, it opens up the navigator for you. Got in?
Got that. Got that.
Yeah. And your navigator is where you select what file are you connecting to. So if you look at
Thanks.
this now, we have D model 1, D region 2, fact sales, LOB, table 2. Then we have DLOB, D model, D region, data, dates. What can we notice here? Some of these are repeated. If you look at the first set of fields that you have here, they are the tables, and we have the worksheets. Are we together? I think someone needs to mute. So we have the tables and we have the worksheet. So if I come to this Excel, just so we are clear, if I on this data now, the worksheet name is data. And that is what we can see on the navigator here. This is data here. But this same data, if I click on it and then I go to table design, you see that it has a name, fact sales. fact sales. If I come back to the navigator, I'm meant to see fact sales. So you see fact sales here. So it's your choice really to select, are you connecting to the table or you're connecting to the worksheet? What is the implication? If you are connecting to the table, it will only connect to this table, start to finish. But if you are connecting to this worksheet, which is data, then it will connect to this table and any other thing that you have here. Do we understand that? Can I proceed?
Please say that again, sir.
Please
Okay.
repeat again more.
Okay, so what I'm saying is, if you look at our navigator, we have the table files and we have the worksheets. So this data is the worksheet name here. That is the worksheet name here, data. And the table that is sitting on this data worksheet, if I go to table design, I will see the name. It's called fact sales. That's the table name. And that's why you have fact sales on this navigator as well. So what this means is that if you are connecting to a table like fact sales, if you are connecting to a table like fact sales, then any other thing outside of this table will be discarded. But if you're connecting to a worksheet, it will come in with this table and any other thing that you have with it. Clear now? Is it clear or still not clear?
So it's preferable to connect to the table, not the worksheet. Is that what you're saying?
Correct. So connect to the table itself. So you're sure that you're not connecting to any remnants around the table. So here I'll come here, I'll select the tables that are here. So just check the boxes. So I'll just check the boxes, connect to all of this table. Let me see what's this table 2. Okay, I think this is the date table here. It's not named properly. And once I connect to all of them, because this data is clean, so I will not transform, I'll just click on load. The data is clean already. So I'll transform, I'll click on load rather. So this will load it into my Power BI. So I should get them on the fields as soon as they come in. Okay, so if you look at the fields now, you see that we have all our tables there. These are more, if I come to the data view, so this is our model. These are the unique models. We have the region. So we have the region, the market, and the store. We have the fact sales, which is for our transactions. We have LOB. These are a unique line of business. We have just 4. And this our dates. So if I come to the model view now, you see that on the model view, we already have some connections between our table. Why was this connection created? Because Power BI was able to sense that there are some common fields, common columns between our different tables. And if you look at the model, for instance, you have model here and you have model on your fact sales. And that's why there's a connection between the two. So it is using model on the model to connect to the model on your fact sale. So which means that your model here is the key. So which one is the primary key and which is the foreign key? Which one is the primary and which one is the foreign key?
So I think the model 1 will be the primary key.
Okay. And this one will be the foreign key.
Yeah, will be the foreign key.
Correct.
Just
so now. Yeah, correct. Thanks for that. So if you come to the D model 1, you will see that we have just unique values here. So we have said that your primary key would house your unique values. So if I come back here, our unique values are here, and that's why you have 1 here. So 1 here on the D model table is telling you that you have unique values here. You have 1 instance of each data plot, each element that you have on this table. Just a single instance of that occurs, and on the fact sales table you have many instances of those. That's why you have an asterisk here. So the same thing, line of business to your fact sales. So line of business is connecting using the line of business key, and you have a 1 side which is on the LOB, which is the unique side, and you have the many side on the fact sales, and the same thing on your region. So sometimes you have a situation like this. Some of your data tables are naturally connected automatically, but you have a few other ones that are not connected, and there are reasons for that. So if you look at our table here, table 2 and the fact sales, they are not connected yet. So which means that we will need to do that ourselves. What would be the key between the table 2 and the fact sales? What would be the key here?
Look at the dates in table 2 against the trade date in fact sales.
Excellent. So the date here is the same, or is as the same data plot as the trade date that we have here. So how then do we go about connecting? Different ways, but the fastest way is just to drag whatever you want to use to create that connection. Just have it highlighted this way and hold down your left mouse and drag it. Just the normal way we drag things, you can see it's out, and then I will drop it on my trade date. So I'll drop it here. Once I drop it here, you'll see that a relationship has been established, and now we have our data model. So everything we see at the top, where we have 111, they are the dimension files, they are the attributes, and this one, which is the transaction file, which has all the duplicates or the records of our transaction, is what is called a facts file. So we have created a data model. I think now probably we understand what data modeling is, why do we need a data model, and how do we create a data model. That is what we have been able to look at in say about 70 minutes or thereabout. So if we have questions now, I would be happy to take them.
Okay. Thank you, Muhsin. It's very exciting. I just want to have a question, right?
Okay.
For instance, if I'm connecting to now with what we just did now, we worked with an Excel file.
Yeah.
If I'm connecting to different data source, does it also follow this pattern, or there is another way we have to go around it? And then secondly, I realized that this is my own out of the box thinking now. The reason why the table 1 and the table 2 could not connect with the fact file is because their column name was not the same. Could that be the reason? That's
okay.
That's on one hand.
Okay.
And then just still on that, what if the date formats in both tables are in different formats? Even if their names are correct, would they still are we still able, are we going to still be able to create that relationship between them? That's between
Okay.
table 2 and fact sales.
Let me begin with the last question. So what you mean by date format is, say we have something like this here.
Yes.
We have a format like this here.
Yes.
1/8/2014, and on our fact sales, we have the full days like this.
Yes.
Okay, that is not an issue. So they say that a format only changes what you see. It doesn't change what the actual data is. So formatting the date as this line here still means 28/4/2015. That's what it still means. the formatting only affects what we see. It doesn't change what is behind.
Okay.
You get. So if the formatting are different, that does not in any way affect the connection. So far it's date. You're looking at the data type and it's date, then the relationship will be established.
Oh, okay.
So yeah. The second thing is, if we come to our data model and we realize that our tables are not connected, one of the reasons which you have just mentioned is that the column names differ. And that's most times the reason why the connection is not established. The column, if our column name here is trade date, most likely the relationship will be established. And that was one of the reasons which assisted us with the other thing. So model is connected straight up with model. Your line of business is connected to line of business. So if these are different in a way, it may not connect directly, or if there are certain things within the data itself, maybe you're looking at your line of business, it has some additions that probably does not exist in your fact sales, which is another issue that you may need to deal with when you are cleaning your data. But majorly, what would make your data not your tables not connect automatically is partly due to the names not matching. And lastly is you mentioned if you asked if you're connecting to different data sources. What sort of data sources? Like you're connecting to Excel, then CSV, then text file, then PDF. Is that what you mean?
Okay, so, something like that, or maybe one of my data sources, a database, say from an SQL, a database per se.
Okay, so if you're connecting to different data sources, instance A is you're connecting to Excel and CSV. The same way is how you create your data model. It works the same way. So just have maybe this one is an Excel. We have loaded it into Power BI. Then go to get data again, go to CSV, text or CSV, then load in the CSV file. So once you load it in, you see that on your model as well, and you can create a connection between them. It's the same way. But if you're working with a database, it depends on the way you are connecting to that data. There are two types of connection you can do. You can do what is called import, or you can do what is called a direct query. So import means that you are importing the data from the database, which means you are creating a copy of that data, pulling it into your Power BI. So there will be a physical copy of that data in your Power BI. You are importing. That's what that means. Direct query means that you are not pulling in a physical copy. You are just creating a medium to speak to that database. So the physical data is not coming into your Power BI, but what your Power BI would only be able to do is to create or to speak to that database because you have signed in with your credential, you have identified the data, the table you want to work with, and it's able to talk to that table, but it's not extracting the data and pulling it into your Power BI. Do you understand that?
Yes, I do.
Okay. So now, if you are doing an import, you are pulling in your data, which means you have a physical copy of that data on your database, on your Power BI, sorry. And then you now bring in an Excel file into your Power BI, which means you have a physical copy of the data from your database, and you have your Excel data also on your Power BI. You can create a relationship between the two. But if what you have done is a direct query, which means your physical data still sits within your database, you have not imported it, then you now have another Excel file within your Power BI, you will not be able to create a relationship per se.
Okay.
Do you understand that?
Yes, I do.
So it depends on the kind of the way you are relating with your database. How are you bringing in your data? That's one of the things that will define whether you will be able to create a relationship between it and other data sources or not. But you need to have all of this well defined, well thought out before you start to work with Power BI. So there is usually a design phase for when you are building report or you are running analysis on an enterprise level. So you have the design phase, you have a clear picture of what you want to do, and that will drive whatever you need to put together, how you are going to query your data, what kind of relationship you're going to build within your data model and stuff. Okay. So
just fine.
okay.
So if I get you correctly, one like what it means is that if we are for that that last question I asked, that date relationship. So that means my data type is very key in terms of that relationship for it to work. That means both of them on data type.
Yes. So, and also aside from for relationship's sake, for whatever analysis you're running, one of the very essential things you must ensure you ascertain when you are doing your data transformation is your data types. Because for instance, now, if I come to my data view and this my revenue, if you look at my revenue, you see that the data type is all number. If this is changed to text for whatever reason, this is changed to text, you would not be able to perform calculations on it. If you are trying to do some aggregations on this, you might be getting some errors. Or if you are trying to do some binning or grouping on this, you might be getting some errors because of this data type. So data type is very essential when you are creating reports, not only for data modeling sake, but for anything. So when you are transforming your data, one of the key things you need to ensure that you have correctly and well spelled is your data types. So ensure that for date should be data type. For your region, it should be text data type. Revenue should be whole number or a fixed decimal. Your unit sold should be whole number. Have all of those well defined when you are doing your transformations. I don't know if that's clear.
Very clear. Thank you so much. Thank you.
You're welcome. All right. So any other question? Okay, I think we are right on time. Something. I think I'm done.
Yes, thank you, Muhsin. Thank you so much. That was really insightful. I don't know if there is any other question, but we'll call it the. All right, thank you, Muhsin, so much. That was really cool one. And for those of us who were able to join, I want to say kudos to you guys. We'll meet same time next week to continue with what we have next, which is introduction to creating DAX measures. We'll be looking at the implicit measure first before going into the explicit measure, for which we'll be focusing on time intelligence formula in order to create or build a report using our data, which we've modeled today. So let's just try to practicalize what we've learned so far, and I'll see you in the next session. Thank you, Muhsin. Thank you, everyone, for making it to the session today.
Yeah, thank you.
Thank you. Thank you. Hope we'll be getting the recording.
Thank you, sir.
Thank you, Samson.
Yes. So I'll be sending the recording as usual. Yeah.
Thank you, Samson. Thank you, Muhsin. Thank you, everybody.
Thank you
All
so
right.
much, Mrs. Thanks.
Yeah, thank you.
Thank you. Thank you, Mr.
All right.
Thank you, everyone.
Okay. So I'll be ending the session now. Let's take care. Bye for now.